Okay, so this assignment is very much a kind of a retro assignment, but yet new stuff. Just kind of repackaged. So let's start with this idea of torque. So if I've got a meter stick, which I have to, so if I go to balance it and I put a small weight on one side way out here, where would I put a larger weight to make it balance? Even further out or closer to the center? Closer to the center. Why?
Because the radius is smaller. So you have to match
so if I'm right here in the middle, so I've got a small weight out here, small weight, big radius. To balance that out, I'd have to have a big force with a small radius. Okay? So, one of the things that, especially in biology or production of some chemicals, we take advantage of the fact that certain molecules have a polarity. They have like a positive and negative input. So water is a classic example of that. So the sketchy thing that I have back here, as going into Jane Carroll put it, so we're going to have to give that a spin. So this is kind of
Hey, can you let me record?
So, what I'm going to do is that I'm going to generate a stream of water that's going to be coming out, and then I'm going to charge the balloon and put that close to the stream of water. So, Jane, safety, and just kind of put your hand on that. Okay, so if I get this going, and just put a little bit of a stream of water. Okay? And if I just put the balloon near it, nothing happens. Okay? Because it's not charged. But if I charge the balloon, Kellen, I might have to borrow your hair.
Okay. Might be full of electrons. I've taken them all.
So now when I bring that balloon close, what does the water do?
It curves towards the balloon.
It curves towards the balloon. So what does that tell you about the water? A couple of things that could happen with the water. What's one option?
Neutral.
Water's just neutral. And when I do that, what do I do with the electrons that make up the water? They push them away. Now, the other option is that water has a positive charge. But what I want you to see out of this is that if you look at those water molecules and you have a positive and negative end, the oxygen, well, I'll draw this in just a second, but the oxygen end of the water molecule is very negatively charged, and the positive end of the hydrogen end of the water molecule is positively charged. So you have a negatively charged oxygen end, and you have a positively charged hydrogen end. So when I put this electric field close to this, you have two things that are happening that really make this thing attract towards it. So the positive, if this is negatively charged, the hydrogen end of the water molecule is being pulled towards that. Okay? Plus, this has this big negative end. So the hydrogen end of the water molecule is pulled towards it. Then it's driving because this is negatively charged, it's going to drive the electrons on the water molecules away, which is going to force that protons in the oxygen to even be more attracted to it. So this is why this is drawn towards it. So here's what I want you to get out of this, is that you can take an electric field and distort molecules and how they move through the air. Got that visual? Okay. Thank you, Jane Carroll. Hold on. We'll keep holding that. Okay. Just made it got off nice. Okay. That's it. All right. Back to work.